Okay, बताता हूँ. Yes, anyone know?
So last day you explained the proxy ARP regarding this thing. So you asked us to remember one
Okay.
protocol. When we
Last
ping,
class. Mm-hmm.
so when we ping to when we ping the destination address, first packet will go and second packet will change the MAC address of the destination. So you
Yeah.
asked us to remember this thing,
Yeah.
proxy ARP.
Correct. Now I'll verify these things. Okay. Now I'll verify these things. Okay. So okay. Let's make a topology. Let's say this is R1 and this one is R2 and this one is R4. Okay. And no, it's R3 and it's R4. Right. So let's say here we have 4 devices. Okay, R1, R2, R3, and R4. Okay, so guys, you know what is static routing? Static routing.
We need to manually add the all the routes and all the routers. I mean next stop IP addresses.
Okay. It means using the static routing, we need to specify the particular network, right? Using the next
Yes,
hop IP, correct? Yes,
yes.
super. So, okay, let's say what I can do. Let's say this is my router. Okay, and these are the PCs. And this router is connected with this PC. Okay, and we have one more PC like this. Okay, after that, let's say this PC having IP address 10.1 and this PC having IP address 10, 20, 30, 40, 50. Let's say that is 50.1. Okay, and here we have 50.100 and here we have um, 10.100, right? In between R1, R2, let's say here we have 20.1 and here we have 20.2, right? In between R2 and R3, 30.1 and then 30.2. In between R3 and R4, here we have 40.1 and then 40.2, right? Okay, so this is the topology, right? Now, so in that case, okay, just a minute, guys. Okay, now, so this is the topology, right? Um, Now, what I can do first of all, we need to check, like, first of all, we will configure the static routing, right? So, guys, on R1, let's say by default, when we configure the IP address, immediately the device will maintain the routing table, right? So let's say this R1 having routing table and this R1 having two interfaces, okay, two ports we can say. The first one that is F0 by 0 and the second one that is F0 by 1. In R2, here we have F0 by 0 and then what F0 by 1. Okay, in R3, let's say here we have F0 by 0 and then F0 by 1 and R4 here we have F0 by 0 and then F0 by 1. Okay, so these are the ports, right? Now, so okay, let's say once I configure the IP, immediately this R1 router will maintain the routing table. So by default, R1 having two interfaces, F0 by 0 and F0 by 1. So on F0 by 0, what is the network address? On F0 by 0, the network will be 20.0, right or wrong? This is clear to everyone, right? On F0 by 1, the network will be 10.0, right or wrong? Okay, and exactly same on R2. We have two interfaces, F0 by 0 and then what? F0 by 1, right? On F0 by 0, the network will be 20.0. Okay, on F0 by 1, the network will be that is 30.0, right? On R3, F0 by 0 having 30.0 network. Okay, F0 by 1 having 40.0 network. Okay, and on R4, here we have 40.0 on F0 by 0. Okay, on F0 by 1, here we have 50.0, right? Right. So this is the routing table. Let's say I'm not doing everything, just I assign the IP address. So when I assign the IP address, same time the device will maintain the routing table. That's it. Now, in that case, what will happen? Let's say now we need to do a static routing, right? So we need to configure how many networks? Now we need to configure 20 and 40 and 50 network on R1. 20.0 and then what? 30.0 and then what? 40.0. Okay, we need to configure these three network on R1, right? And these three network will receive from R2 router. Okay, from R2, correct? Exactly same. If I talk about R2, so on R2 we need to configure which one? We need to configure 10.0 and then we need to configure 40.0 and then we need to configure 50.0. Okay, and this 10.0, this 10.0 route is received from R1. Yes, guys, have any question? Anyone? Hello? Yes. Ankit, mute from your side, please. Okay, and this 40.0 and then 50.0 will receive from R3. Okay, and if I'll check on R3 router, so we need to configure here 10.0 and then we need to configure here 20.0 and then we need to configure here 50.0. Okay, so this 10 and 20 will receive from R2, right? And this 50 network will receive from R4, correct? And exactly same if I talk about this R4 router, right? So here we need to configure 10, 20, 30. So I'll configure here 10.0 network, 20.0 network, and then what? 30.0 network. And these three route is received from which router? From R3 router, right? Okay, cool. So now, in that case, let's say I'll do the ping, right? Okay, this is the PC1 and this is the PC2. Okay, so let's say I'll do the ping from 10.1 to 50.1. In that case, what will happen? What will happen in that case? You know, guys, whenever if I do the ping from one network to another network, so the first packet will be that is for the default gateway, right? Okay, in that case, once I'll do the ping, yes, the source IP will be 10.1 and the destination IP will be that is 10.100. This is the default gateway, correct? Perfect. So in that case, what will happen? Let's say in this interface, the MAC address will be that is 0A. Okay, no, 0A, and here we have the MAC address will be 0B, 0C, and then 0D. And here we have the MAC address, this PC having MAC address 0H, let's suppose. Okay, it's just example. Now in that case, what will happen? Let's say I'm doing the ping from 10.1 to 50.1. Okay, so in that case, the first packet will be the source IP will be 10.1 and the destination IP will be 10.100, right? The device will send the ARP request towards the default way, right? And this, after that, it will get back reply, right? It means this PC1 having IP address 10.1 and the MAC address 0H, okay, it will get back the ARP reply. So the IP will be that is 10.100 and the MAC address will be that is it's 0A, right or wrong? In that case, again in the second packet, the device will send the packet again. So the source IP will be 10.1 and the destination IP will be 50.1, right or wrong? Because I told you the first packet, yes, superb. The first packet will be source IP will be the our IP, okay, and the destination IP will be that is default gateway IP, and the destination IP, the source IP will be our IP, and the destination IP will be that is real destination, right? Okay. Now In that case, this is the first packet we can say. Okay, now I'll make a, sorry, this is the first packet, not second packet. This is the first packet. Now I make a second packet, right? So in the second packet, what will happen? In the second packet, the source IP will be again that is 10.1, but the destination IP will be 50.1. Okay, and the source MAC address will be 0H 0H, and the destination will be, that is 0A, right? Right or wrong?
Sir, I think it is 0B to 0C, right?
No. Right now, see, first of all, the device will send the packet towards the default gateway, right? Default gateway will get back reply. Again, the device, this is the first packet, okay, from PC1, and this is the second packet from PC2. I told you, in the first packet, the source IP will be 10.1 and the destination IP will be default gateway IP, right? But in second packet, the source IP will be real source IP and the destination IP will be, that is real destination IP, that is 50.1. And in that case, the destination MAC address will be, that is default gateway MAC address. Okay, this is clear? Yes, guys, any doubt till this point? Yeah, super. Okay, in that case, what will happen? Actually, what will happen? This IP will be 10.1, right? This IP will be 50.1, sorry. Okay, now, so when this this packet with the source IP 10.1, destination IP 50.1, this packet will reach this R1 router, right? So once this packet will reach this R1 router, it means this R1 router will receive the packet with the source IP 10.1 and the destination IP 50.1, right or wrong? Now, in that case, the device will check the routing table. We have any 50.0 network in our routing table? Yes, we have. We have 50.0 network. Okay, here I need to configure 50.0 network as well. We cannot configure 20.0, 50.0, that is 50.0. Now, so once this R1 router will receive this packet with source IP 10.1, destination IP 50.1, now it will check the routing table. We have any 50.0 network? Yes, we have, right? Yes, we have this 50.0 network. In that case, what will happen? And this 50.0 network will receive from which router? From R2. In that case, this R1 router will send this packet again. Again, the R1 router will send the ARP request to this 20.2 IP, right or wrong? Okay. In that case, what will happen? That is the problem here. Actually, once I let's say, we can say, once I disable the proxy R in this R2 router, right? The device will send this packet to here, and in that case, inside the packet, what is the source IP? The source IP will be 10.1 and the destination IP will be what? That is 50.1. Now the device will send this packet to R2, right? So when this R2 router will receive this packet, in that case, what will happen? The destination IP will be what? Destination IP क्या है यहाँ पे? 50.1, right or wrong? Destination IP क्या है? 50.1 है ना? But still, see, the device will, this R1 device will send the ARP request to which one? To this 20.2 IP. But inside the packet, the source IP will be 10.1, the destination IP will be 50.1. Okay, and the source MAC address, this interface MAC address, that is 0B, and the destination MAC address, that is FFF, because this is the ARP request, right? In that case, the device will send this packet to R2. Now, when this R2 router will receive this packet, okay, it will know, okay, this is the ARP request, right? Now it will get back the reply. In case of reply, what will happen? The source IP will be 50.1, destination IP will be 10.1, source MAC address will be what? This interface MAC address 0C, and the destination MAC address will be 0D. So guys, actually there is a problem. What problem? Actually, this 0 See, MAC address is which IP of MAC address? This MAC address will be 20.2 IP, right? But here, this 0C MAC address will add inside the 50.1 IP. So that is called using the proxy ARP. We have add this IP. Okay, because by default on the Cisco devices, on all Cisco devices interface, the proxy ARP will be enabled, right? So once I disable, let's say once I disable this proxy ARP, so what will happen? So once the device will send the ARP request again, let's say let's say I disable the proxy ARP in this interface, right? Okay, disable the proxy ARP in this interface. Now this R1 device, will send the ARP request to this IP, right? And inside the ARP packet, the source IP will be inside the ARP packet. The source IP will be 10.1. Destination IP will be 50.1. Source MAC address 0C. 0B. 0B. Destination MAC address FFFF. Right now, once this R2 router will receive this packet, so what will happen? Once this R2 router will receive this packet, in that case, the device will check, okay, we have any 50.1 IP address. It means the device will check this 50.0 network is directly connected to R2 router. No. देखो भाई 50.0 नेटवर्क जो है वो R2 राउटर से डायरेक्टली कनेक्टेड है क्या? नहीं है ना. बट देखो जब फर्स्ट टाइम आरप आई थी तो उसने रिप्लाई दे दिया था. क्यों? क्योंकि प्रॉक्सी आरप इनेबल था. इन दैट केस R2 जैसी पैकेट को रिसीव करेगा, when this R2 router will receive this packet, so the device will check, okay, what is the destination IP? Right now the destination IP will be 50.1, right or wrong? अब ये चेक करेगा कि 50.1. अभी R2 चेक करेगा क्या मेरे किसी भी इंटरफेस पे क्या 50.1 IP है? नहीं, तो मैं उसका रिप्लाई नहीं दूंगा. मतलब अगर मैंने प्रॉक्सी ऐप डिसेबल कर दी और इसने आर्क सेंड करी तो आर्क का रिप्लाई नहीं देगा, राइट? एंड आर्क टेबल में आपका क्या लिखा हुआ आएगा? इनकम्प्लीट. ओके, यस गाइस, दिस इज क्लियर. एनी डाउट टिल दिस पॉइंट? एनीवन? इट मीन देखो क्या कर रहा है प्रॉक्सी आर्क का बिहेवियर क्या है कि अगर मैंने किसी और आईपी के लिए आर्क सेंड करी है तो क्या करेगा वो अपने इंटरफेस का मैक एड्रेस लगा के उसका आर्क का रिजॉल्व कर देगा, आर्क को रिजॉल्व कर देगा, राइट? दिस इज द प्रोसेस ऑफ आर्क. क्योंकि अगर मैं ये नहीं करूंगा ना, सो वी आर नॉट एबल टू कम्युनिकेट, राइट? सो दैट्स व्हाई बाय डिफॉल्ट ऑन द सिस्को डिवाइसेस द प्रॉक्सी आर्क विल बी enabled, राइट? देखो मैंने लेट सपोज R1 R2 से फिर से आर्क सेंड करी R3 को, राइट? किसके लिए? लेट से इस इंटरफेस का मैक एड्रेस क्या है? 0G. ठीक है, मैंने 50.1 के लिए मैक एड्रेस आर्क सेंड करी, बट R3 के पास 50.1 तो है नहीं. अब अगर यहाँ पे प्रॉक्सी आर्क इनेबल है तो ये इसका रिप्लाई दे देगा इस मैक एड्रेस को लगा के, राइट? बट अगर प्रॉक्सी आर्क डिसेबल है देन वो क्या करेगा? वो रिप्लाई कभी भी नहीं देगा. वो पहले चेक करेगा अपनी राउटिंग टेबल है. if this 50.1 IP is available, then only it will get back the reply, right? This is clear to everyone? Yes, any doubt till this point? Anyone? चलो इसको वेरीफाई करते हैं. Now I'll show you. Yes guys, any doubt till this point? Anyone? Ankit, Durga, Nirjar, Rajesh, Razak, Trilek. Okay, super. ठीक है. Now I'll show you. So now I'll show you like first of all by default the proxy ARP is enabled, right? So now I'll show you like how to disable the proxy ARP, these things. Okay. let's say this is the PC, okay, and this PC having the IP address 10.1. Okay, just a minute. This interface, the IP will be 10.1, and here the IP will be 10.100. Here the IP will be 20.1, 20.2, 30.1, 30.2, .1, and then no, it's not 40.1. That is 40.100 and 40.1. Right. So this is the topology. Now, first of all, I'll configure the IP address. Then we'll discuss everything. So first of all, we need to configure the IP on R1. On X0 by Z, the IP will be 10.100. It is 192.168.10.100, say 255, 255.0, and then say no shut interface F1 by 0. IP address 192.168.20.1, say 255.255.255.0, say no shut. Okay. Now on R3, interface F0 by 0, 192.168.20.2, and then say 255.255. 500 interface F1 by 0, and then say 192.168.30.1, say 255.255.255.0. IP interface brief. Okay, so these are the IP address on R3. Now we need to configure on R4. So on R4 we have one single interface. Sorry, we have two interface. 30.2 and then say 255.255.0 interface F1 by 0, and here the IP will be 40.100. 40.100, say 255.255.255.0, say no shut, and that's it, right? So yes, we will configure the IP address on these three routers. Now we need to configure this IP on these PCs. Okay, these are the PCs. Okay, we are using no IP routing command here, right? On R3 and R5. Now I convert this router from router to the PC, so no IP. Say enter IP default gateway. The default gateway will be 10.100, say 255.255.255.0. Enter interface F0 by 0. What is the IP? The IP will be 10.1, 255, 255.0. Okay, that's it on R2. Now we need to configure on R5. No IP routing, IP default gateway. The default gateway will be 40.100, say 255.255.255.0, and then say no shut. And then f0 by 0 IP address 192.168.40.1 do w1, right? Okay, so and now everything is fine. Now I'll configure the IP address on these routers. So now what I can do, now we will do the static routing on R1 and then say IP route. Okay, just a minute. Yeah. So I say IP route on R1 30.0 say 255.255.255.0 and the exit interface will be, ये कमांड पता है किसी को? यस, एग्जिट इंटरफेस पता है? अभी तक जो आपने देखो, no 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 no, it's a next hop IP, right now the next hop IP will be 20.2, right? Static routing को करने के लिए ना एक और कमांड होती है, हम static routing को using exit interface कर सकते हैं, right? and using next hop IP कर सकते हैं, using both कर सकते हैं and using null interface भी कर सकते हैं, right? Okay, right, so now I can do using the exit interface, right? so exit interface क्या है, मतलब कि देखो आपके हिसाब से भी नेक्स्ट ऑफ आईपी क्या होगा, नेक्स्ट 20.2, राइट? बट अगर R1 से पैकेट एग्जिट होगा, सो राइट नाउ व्हाट इज द एग्जिट इंटरफेस, दैट इज f0/1, राइट और रॉन्ग? सो राइट नाउ my best exit interface will be that is f1/0, right? so I say here fast ethernet 1/0 and then say enter, right? exactly same. 30 हो गया, 40 के लिए कर लेते हैं 40.0, that's it, right? Done. Now on R3 IP route 192.168.10.0.255.255.255.0 and the next hop IP will be, sorry, the exit interface will be that is 0/0 and then say IP route, yes, superb. IP route and then here 40.0 say 255.255.255.0 and the exit interface will be fast ethernet f1/0 say enter, that's it, right? On R4 now we need to configure on R4 IP route 192.168.10.0 say 255.255.255.0 and 10.0 for 10.0, so the best exit interface will be that is f0/0 and for 20.0 that is f0/0, correct, right or wrong? Now in that case what will happen, now I'll do the ping, right? Let's say I'll do the ping from R2, from R2 40.1, so yes, 100% it will be communicate, yeah, not to be communicate, right or wrong? Perfect. Now what I can do, show ARP R. Now I'll show you the R table, right? In that case, one more thing I'll show you here on R3 router. 20.2 IP and now we need to check on R3. Run interface f0/0. 0. Now I need to check the MAC address of that interface. So what is the MAC address? This is the MAC address. CA03 and 4 times 0, CA03. Okay. And now when the device will send the ARP, so in that case, on R1, the device will send the R. Once I want to communicate here, then the device will send the packet F1 by 0 to show ARP 30.1, 30.2. Um, 20.2. Yeah. So the device will send the same packet with 30.1. The device will send the ARP request for 40.1. Okay. For 40.1, the MAC address will be, that is this one. So actually, this is the MAC address of 30.2. These MAC addresses learn by the statically, and these MAC addresses learn dynamically. Now I'll show you an R3. So R1, R, yeah, super. Now, अब देखो हो क्या रहा है? In that case, ध्यान से देखेंगे. First of all, let's say I want to communicate. These are the IP addresses, correct? Let's say I want to communicate from 10.1 to 40.1, right or wrong? Okay, from 10.1 to 40.1. So the device will send the ARP request for the default gateway, right? It means this is the first packet, and the first packet will be 10.1, 10.100, and let's say the MAC address will be 0A, 0B, 0C, 0D, 0E, 0F. Okay, like this. Okay, in that case, source MAC will be, that is 0A, and the destination MAC will be FFFF. Okay, so one device will send the ARP request in this interface, right? Now, this R1 router, the device will check the destination IP. What is the destination IP? Right now, the destination IP will be 10.100. Now it will check, we have any 10.100 IP? Yes, we have. In which interface? Interface F0 by 0. And on interface F0 by 0, what is the MAC address? That is 0B. So now the device will get back the reply. Okay, replies look like this. Like the source IP will be 10.100. Destination IP will be 10.1. Source MAC address 0. Destination MAC address what? 0. This is the first packet, right? Yeah. In the second packet, what will happen? The source IP will be 10.1. The destination IP will be 40.1. Okay, no problem. Source IP will be 0A. Destination MAC address, sorry, source MAC address 0A. Destination MAC address will be 0B. Right or wrong? No problem. Okay. Now the device will send this packet to again this R1. Again, this R2 will send this packet to R1, right? And once this R1 router will receive this packet, so it will check, okay, what is the destination IP? What is the destination IP? That is 40.1. That is 40.1. Yes, correct. Now the device will check the routing table. show IP route. The device will check the routing table. Inside the routing table, we have any 40.0 network. Yes, we have. देखो एक लाइन बोल रहा हूँ, ध्यान से समझना, इंपॉर्टेंट है। देखो जो स्टैटिक राउटिंग करी है ना हमने, वो दो तरीके से करते हैं हम। एक तो यूजिंग नेक्स्ट हॉप आईपी एंड सेकंड यूजिंग exit interface, right? The second one using the exit interface. What is the difference? Yes, any idea what is the difference? देखो पॉइंट समझो, यहाँ पे देखो मैं आपको ना एक चीज दिखाता हूँ। इस लाइन को पढ़ो पूरा पहले, क्या लिखा हुआ है पूरी लाइन में, क्या लिखा हुआ है देखना। 192.168.40.0/24 is directly connected on F0 by 1 interface. ये R1 की राउटिंग टेबल में दिखा रहा है, क्या बोल रहा है, कह रहे हैं कि F1/0 इंटरफेस से 40.0 का नेटवर्क डायरेक्टली कनेक्टेड है। क्या ऐसा है एक्चुअल में? यस, बताओ, है क्या ऐसा एक्चुअल में? है ऐसा? नो
No, sir.
बट इट विल शो मी, राइट और रॉन्ग, बट स्टिल इट विल शो मी। अब देखो पॉइंट क्या है, पहले क्या होता था इन केस ऑफ नेक्स्ट होप आईपी, वो आप रिक्वेस्ट किसको सेंड करता था? नेक्स्ट होप को। किसको? 20.2 को। व्हेन वी कॉन्फ़िगर द नेक्स्ट होप आईपी इन दैट केस, बिकॉज़ वहां तो नेक्स्ट होप आईपी मुझे पता है, हाँ भाई आप किसको सेंड करनी है? नेक्स्ट होप आईपी को, राइट और रॉन्ग? मुझे आप किसको सेंड करनी है? नेक्स्ट होप को, राइट? बट इस केस में तो नेक्स्ट होप है ही नहीं भाई। पहले क्या, अगर मैंने अभी एग्जिट इंटरफेस करता है ना, तो पता है कैसे लिखा राउटिंग, ऐसे 192.168.40.0/24 और नेक्स्ट होप आईपी क्या लिखा होता? 20.2। ध्यान से देखना, तो मैं आर किसको सेंड करता? R1 से, जैसे R1 के पास ये वाला पैकेट आता, सेकंड पैकेट विद सोर्स आईपी 10.1 डेस्टिनेशन आईपी 40.1, तो मैं पहले देखता क्या मेरी राउटिंग टेबल में 40.1 है, हाँ भाई 40.1 है, और नेक्स्ट होप आईपी क्या है? 20. तो मैं क्या करता, यहाँ से 20.2 को क्या सेंड करता? दिस इज क्लियर टू एवरीवन? से यस और नो? कूल, सुपर। क्लास में एक ही बंदा है क्या यहाँ पे, और कोई नहीं पढ़ रहा है क्लास में? ओके ओके, अगेन आई रिपीट दिस। सी देखो पॉइंट समझो, मैं देखो ये समझ आया, ये वाली जो कमांड है वो कौन सी है? यूजिंग द नेक्स्ट हॉप आईपी। जब आप नेक्स्ट हॉप आईपी से कॉन्फ़िगर करते हो ना कभी भी स्टैटिक राउटिंग, इन दैट केस व्हाट विल हैपन, वो अपनी राउटिंग टेबल नेक्स्ट हॉप आईपी लगा देता है। ये नेक्स्ट हॉप आईपी लगा दिया इसने, राइट? और जब आप एग्जिट इंटरफेस के थ्रू करते हो तो वो कोई भी नेक्स्ट हॉप आईपी लगाता है। ये मैंने किया हुआ है यूजिंग एग्जिट इंटरफेस, ये वाला, ये देखो, ठीक है? तो अगर मैंने ये वाला कॉन्फ़िगर किया है यूजिंग द एग्जिट इंटरफेस, तो जब जैसे पैकेट R1 पास आया, R1 ने पैकेट देखा, द सोर्स आईपी 10.1 डेस्टिनेशन आईपी 40.1, अब इससे राउटिंग टेबल चेक किया, क्या मेरे राउटिंग टेबल में 40.0 का नेटवर्क है? देखना, हाँ बिल्कुल है। अगर मैंने नेक्स्ट आईपी वाला कॉन्फ़िगर किया होता तो अभी क्या रहेगा कि नेक्स्ट ऑफ आईपी क्या है? 20.2। अब इसने क्या करा, नेक्स्ट ऑफ आईपी को इसने आर्प सेंड कर दिया, ठीक है? चलो, ये तो था नेक्स्ट ऑफ आईपी का कॉन्सेप्ट। बट अब क्या हो रहा है, अभी तो मैंने नेक्स्ट ऑफ आईपी तो कॉन्फ़िगर नहीं किया हुआ है, अभी तो मैंने कौन से कॉन्फ़िगर किया है? यूजिंग एग्जिट इंटरफेस। okay okay, no problem, click no problem। ओके, सो इन दैट केस देखो अब क्या होगा, 40.0 नेटवर्क जैसी राउटिंग टेबल चेक करेगा, वाला सेकंड वाला पैकेट किसके पास आया? राउटर के पास, R1 के पास। R1 राउटर ने जैसे सेकंड पैकेट को रिसीव किया, इमीडिएटली द डिवाइस विल चेक द डेस्टिनेशन आईपी। उसने क्या चेक किया? उसने क्या चेक किया? डेस्टिनेशन आईपी चेक किया। उस पैकेट पे डेस्टिनेशन आईपी क्या था? 40.1। द डिवाइस विल चेक द राउटिंग टेबल, क्या मेरे पास 40.0 नेटवर्क है? यस बिल्कुल है। और यहाँ पे ये क्या दिखा रहा है कि पैकेट एग्जिट कर दो किस इंटरफेस पे? F0/1 से। तो अब क्या होगा, पहले क्या हो रहा था कि वो आर्क सेंड कर रहा था किसको? डेस्टिनेशन आईपी क्या लगा रहा था? 20.2। क्योंकि राउटिंग टेबल में नेक्स्ट ऑफ आईपी रिसीव हो रहा था मुझे, इसलिए। बट अब मुझे नेक्स्ट ऑफ आईपी रिसीव नहीं हो रहा, तो ये आर्प किसके लिए सेंड करेगा? नाउ दिस R1 राउटर विल सेंड दिस आर्प विद सोर्स आईपी 10.1 and destination IP will be 40.1। ठीक है, अब ये पैकेट आएगा कहां पे? R3 के पास, ध्यान से देखना। So once this R3 router will receive this packet, now it will check, okay, the destination IP will be what? 40.1. Now this R3 router will check the routing table. क्या मेरे पास 40.0 का 40.01 सॉरी 40.1 जो है वो डायरेक्टली कनेक्टेड है? आप बताओ, क्या 40.1 डायरेक्टली कनेक्टेड है ऑन R3? नो, नहीं है। तो देखो, अगर प्रॉक्सी आर्प इनेबल है तो ये झूठ बोलेगा, मतलब प्रॉक्सी लगाएगा। क्या एक्चुअली ये इस इंटरफेस का मैक एड्रेस लगा के इस आर्प को रिजॉल्व करके रिटर्न कर देगा, अगर प्रॉक्सी आर्प इनेबल है तो। और अगर प्रॉक्सी आर्प इनेबल नहीं है तो ये चेक करेगा अपनी राउटिंग टेबल, क्या मेरे 40.1 डायरेक्टली कनेक्टेड है? नहीं है, तो मैं इसका आर्प का रिप्लाई नहीं दूंगा। दैट्स इट। आई विल शो यू दीस थिंग्स, डोंट वरी, मैं आपको दिखाता हूं। देखो 20.2 मैक एड्रेस है यहाँ पे, बी सी एंड डी होगा, ठीक है। तो आर कहाँ पे चलते हैं? चलो R3 पे चलते हैं। पहले मैं नॉर्मली पिंग करके दिखा देता हूँ आपको फ्रॉम R2 192.168.40.1 and then say enter. In that case, yes, the device will do the thing 100%, right? But अब एक काम करते हैं, मैं क्या कर रहा हूँ, सारे इंटरफेस को ना शट डाउन कर रहा हूँ, ठीक है, और फिर अप करूंगा। बिकॉज क्या है ना, देखो अगर मैं ना अभी डू शो ARP, मुझे ना आर्प टेबल को ना क्लियर करना पड़ेगा, ठीक है, आर्प टेबल को क्लियर करना पड़ेगा, एक बार रिमूव करना पड़ेगा। तो कमांड वैसे होती है डू क्लियर आर्प कैशे, बट ये कमांड ना वर्चुअल डिवाइसेस में काम नहीं करता है, राइट? सो वी नीड टू डू व्हाट, इंटरफेस रेंज फास्ट इथरनेट F0/0 and 1। एक बार इन इंटरफेसेस को क्या कर दो, शट नो शट कर देते हैं। इंटरफेस F0/0 शट कर दिया, इंटरफेस F1/0 शट कर दिया, इंटरफेस F0/0 फिर से नो शट कर दिया, इंटरफेस F1/0 नो शट कर दिया। R3 में भी ऐसे ही कर लेते हैं, राइट? और R3 इंटरफेस F0/0 फिर शट डाउन, इंटरफेस F1/0 फिर शट डाउन, इंटरफेस F0/0 then say no shut, interface F0/0 say no shut, okay, interface F1/0 again say no shut, on R4 same thing, interface F0/0 say shut down, interface F1/0 say shut down, interface F0/0 and then say no shut, interface F1/0 and then say no shut। ठीक है, आर टेबल में से आर कैश डिलीट हो गए होंगे, यहाँ पे भी ऐसे कर देते हैं, R2 और R5 पे भी। R5 no shut ARP ओके ना। अब देखो एक काम कर रहा हूं मैं, अभी पिंग हो गया था ना, अब मैं R3 पे चलता हूं, आई विल शो यू। मैं ना प्रॉक्सी आर्प को डिसेबल कर रहा हूं। सो हाउ टू डिसेबल द प्रॉक्सी आर्प, व्हाट इज द कमांड, इंटरफेस F0/0 IP प्रॉक्सी। ये कमांड बाय डिफॉल्ट चली होती है ऐसे, ठीक है, ठीक है ना। तो मैं क्या करता हूं, इस कमांड को क्या कर देता हूं, नो, इस कमांड को क्या कर दिया मैंने, नो। अभी क्या करेगा, अब जब इसके पास पैकेट आएगा ना, ये यहाँ पे आर्प सेंड करेगा, बट सोर्स आईपी क्या होगा, 10.1 डेस्टिनेशन आईपी 40.1। जैसे R3 रिसीव करेगा, कहेगा भाई मेरे पास तो कोई भी 40.1 है ही नहीं, तो मैं आर का रिप्लाई नहीं दूंगा। और R1 ने जो आर्प सेंड करी होगी उसका रिप्लाई नहीं आएगा, then R1 show me, R1 device will show me the what R1 will show me incomplete. Okay, R1 मुझे क्या शो करेगा, incomplete शो करेगा in that case, correct? Now I'll show you. Now on R2 I need to do the ping, right? Say do ping 192.168, do ping 192.168 and 40.1 and then say enter. In that case we are not able to communicate, right? In that case we are not able to communicate. Why? Okay, I'll show you. R1 ARP table, do show ARP ARP and then say enter. Okay guys, can you see here? देखो इसने क्या किया, this R1 device will send the ARP request, right? R1 ARP send जरूर किया, but they don't get reply, right? Okay, उनको ARP receive नहीं हुआ, ARP का reply नहीं आया. So that is called proxy ARP. Okay, मतलब इंडायरेक्टली आप कह सकते हो गलत इंफॉर्मेशन देता है. अगर आप क्या करोगे, प्रॉक्सी ARP पे डिसेबल कर दोगे इन एनी इंटरफेस, देन इन दैट केस क्या होगा, वो रिप्लाई नहीं दे पाएगा. ओके, दिस इज क्लियर टू एवरीवन? एनी डाउट टिल दिस पॉइंट, एनीवन?
I have a question.
Yes, tell me.
So, when we are pinging from PC1 to PC2, initially we send one ICMP packet, right? That goes to R1 and
Yes.
it resolves the MAC address of R1, right, sir? So
Yes,
that packet
yes.
will be dropped eventually. So again we are sending ICMP packet second one. This ICMP packet will resolve the ARP protocol and resolve the MAC address of R3, right, sir? So this packet is not getting dropped. Why this second packet is not getting dropped?
See. Actually, see, once the device will send this packet to R1, right? This packet.
Yes.
This is the first packet,
Yes, sir.
right? Okay.
Yes.
This is the second packet, source IP 10.1, destination IP 40.1, source MAC 0A, destination MAC
0B.
0B. Okay, ठीक है, ये पैकेट आप कहाँ पे गया, R1 के पास. Okay.
Yes.
Now when this R1 router will receive this packet, so आपको पता है ना, whenever device will receive any packet, so it will ignore the
MAC address. I mean,
MAC address.
previous. Yeah.
Layer 2, layer 2 packets, right? And it will check the destination IP. The destination IP will be
41.
40.1. Yeah,
1.
40.1. Now this router will check the routing table to show IP route. Okay. The device will check the routing table. क्या मेरे routing table में route है? Yes, the route is available. In which interface?
Yes.
We need to exit in which interface?
1/0.
1/0. So in that case, see, actually the MAC address is removed now, right or wrong?
Yes, sir.
This R1 router will check again once the packet is entered, then the layer 2 will be removed. Okay, and when the packet is exit, then the layer 2 will be added. Okay, so now the device will add this interface MAC address 0C, the source IP 10.1, destination IP 40.1, and the device will add this interface MAC address, that is 0C, but the device don't know what is the MAC address of this 40.1, because the device will check inside the ARP table. We have any 40.1 IP? No, we don't have. So how it will add the destination MAC address here? So that's why we need to send the ARP to 40.1 IP. Okay. Yes, if you have any questions, so tell me again, no problem. बताओ क्या question है again. ये समझ आया? कोई डाउट है?
Sir, that is clear, sir. I understand that part. So
Mm-hmm.
my only confusion is why this second packet is not getting dropped. I mean, we are resolving the MAC address of R3. That part is very clear. But in the first case, this ICMP packet will be dropped. So because of that reason, we are seeing only 4 pings, right? When we ping from one.
Okay. Are you saying like here the first time will be they drop the first packet, right? So again
Yes,
here
sir.
the device will dropping. Okay, what will happen? Actually, Cisco devices is using the CEF table, CEF, Cisco
Okay.
Express Forwarding. Okay.
Okay. Sir, when once you configure the static routing on these routers, when you ping for the first time, there are 2 packets dropped, right, sir? For the first time.
Yeah, actually what will happen here, the CEF table is working, right? CEF table, CEF. That's why the packet is not dropping in the second time. Okay, because CEF is we can say okay, once we start, then I told you these things. Okay, don't worry for this. Okay,
Okay, sir.
once we start the MPLS, so before starting the MPLS, we are going to start all the tables like CEF table, RIB RIB table, FIB FIB table. These table we will discuss. Then I told you. Okay, then this is clear for you. Okay, because we can say CEF is not a look like we can say the CEF is a copy of the routing table, but okay, let's explain you. Um, okay, let's say I want to communicate this 50.1. No, we can say like this. Okay, and now we need to exit interface F0 by Z. So actually what will happen normally, let's say I want to communicate which one? 10.0 network. So once I do the ping this 10.0 network, so first of all the device send this packet to 20.2 and the device will okay 20 dot once I want to reach this 20.2, then we need to go on 30.2. Once I want to reach this 30.0, then we need to go on 40.2. Once I want to communicate this 40.0, then we need to go on 50.2. Once I want to communicate this 50.0, then we need to exit. Okay, it means when I want to communicate this 10.0 network, then we need to look up like this, right? And this is the very hectic task for the router. Okay, so what this is the routing table actually. Okay, so what CEF will do, CEF will say when you want to exit, देखो हो क्या रहा है, आपको 10.0 से कम्युनिकेशन करना है, पहले आप किस पे जा रहे हो 20.2, फिर इस पे जा रहे हो 30.2, फिर किस पे जा रहे हो 40.2, फिर जा रहे हो 50.2, देन आप एग्जिट कर रहे हो F0 by 0. मतलब अगर देखो अगर आपको 20.2 पे भी जाना है, लेट्स से चलो किसी को कम्युनिकेशन करें 20.2 को, तो भी तो आपको एग्जिट F0 by 1 F0 by 0 से करना है. 30.2 पे जाना है 30.0 पे जाना है तो भी इंटरफेस F0/0 से एग्जिट करना है। तो अब सेफ टेबल ने इसको आसान कर देता है, इजी कर देता है। कैसे? ये कहता है कि F0/0 बनाए तो इंटरफेस F0/0 से एग्जिट कर लो, 20.0 पे जाना है F0/0 से एग्जिट कर लो, 30.0 पे जाना है F0/0 से एग्जिट कर लो, 40. जाना है F0/0 से एग्जिट कर लो, 50.0 पे जाना है तो भी F0/0 से। अब देखो मैं लेट्स से आई वांट टू कम्युनिकेट दिस 10.0, then immediately the device will exit in which interface? F0/0. If I want to communicate this 20.0, so immediately the device will exit on which interface? F0/0. So packet को immediately exit कर देगा. No need to like this the lookup thing table like this. Okay. So this is the self table actually. So using the self table, we can't drop the packet here. Okay. Only first time the device will drop the packet, right? Now this is clear. Yeah. So that's it. This is called a proxy. Yeah. Now your all the basic is clear. Now we are going to start the advanced.
Sir,
Yes, बताओ.
any definition about proxy ARP will you give?
Okay, ठीक है मैं बता देता हूँ. मैं लिख देता हूँ यहाँ पे definition. It means we can say um, it is a process to resolve IP address query IP address query, or we can say resolve queries for an IP address that is not on that network. मेरे नेटवर्क में नहीं भी होता. Okay, that not in my network, and we can say the proxy is aware of the location of the traffic destination and offers its OWN on MAC address. Same thing I told you. It will offer on interface MAC address as the destination. That's it. Okay.